All right, number one, let's just forget about it. I don't really like the question. All right, 2, but voltaic would be the right answer. 2. So it's a galvanic cell between these two things. So first off, it's galvanic. It can't be B or D. It must be a positive number. All right. And again, we don't really need to do any math here. If they're both the same sign, it's going to end up being like a real subtraction answer. The answer has to fall between these two numbers. The only thing that would work here is A. 3. All right, at a cathode during a redox reaction, all right, at a cathode, the electrons enter. That means the mass goes up, and the electrons, as they enter, they interact with the ions. That causes the mass to go up. So that's B. So it wants to know what's the half reaction that occurs at the anode. So if we look at these two things, all right, they both want to be reduced. All right, so the one that wants to be reduced the least, which is going to be this reaction down here, that's going to occur at the anode, and because it's going to be oxidized, we have to flip it. We get D. All right. For this reaction, we want to find out, is this reaction spontaneous? So if we look, the Ni is being reduced, the chromium is being oxidized, so we're going to get -0.23 minus a -0.76. Right, that's positive 0.53, and the answer is yes. So for number 5, we get C. Look at that. Neat. All right, 6. It doesn't matter. Always, right? Reduction always takes place at the cathode. Doesn't matter the type of cell, always. All right, so in this reaction, the concentration of B was increased. So Q is products over reactants. All right, so if we increase B, Q is going to be greater than 1. That's like the rubber band. It's already not as pulled tight. All right, so E cell is going to be less than its potential. So B. All right, 8, who's not a redox reaction? Again, look for things where you got elements that are alone and not alone. I'm alone, I'm not alone. Wrong. All right, I'm alone, I'm not alone. Redox. I'm alone, I'm not alone. Redox. There's your answer. Right? If E naught's greater than 0, K has the same sign, greater than 1. Delta G has the opposite sign, less than 0. All right, so. All right, what's correct? In a voltaic cell, it sells, so that one's true. It says electrolytic cells flow from the anode to the other. This is also true, right? Because they still flow, doesn't matter what type of cell it is. And salt bridge sends positive ions to the anode. So this one, though, is not true. So only 1 and 2. All right, so I want to know how many grams of magnesium are produced in this time frame. So we know I and we know T. If we solve for Q, we end up just multiplying the two numbers together. That's how many coulombs we have. There are that many coulombs in a mole of electrons. Now, this is magnesium. Magnesium is going to have a charge of +2. So in order to plate magnesium, we need 2 moles of electrons to get a mole of magnesium. And 1 mole of magnesium is 24 grams. So if we do some quick math here, right, these numbers are about the same. 24 divided by 2 is 12, so it's approximately 12 grams. What's not true about an electrolytic cell? So basically, what's false, right? The space in the anode is oxidized. That's always true. That's always true. That's not true. A salt bridge does what? All right. D. All right, so what occurs at the cathodes? If we look at our two numbers here, this thing is positive, this thing is negative, this wants to be reduced, this wants to be oxidized. Here's your reaction that's going to occur at the cathode. 14 is A. All right, in the overall reaction, if we look, we have 1 electron in copper and 2 electrons on tin. So 1 times 2, least common factor is 2. And if it's now an electrolytic cell, all right, the cathode is still reduction, but instead of the copper being reduced, it's going to be the tin. All right. So we want to know the new molar mass. So we're going to have to find out the number of moles of our element because we know the mass. In order to use this formula, we need to know these two things. We got this already, we just need to know this. So we're going to set it up with I equals Q over T. All right. I is 8.5 equals Q, and then 3.2 times 60 is 192, and then we're going to multiply that by 8.5, and we multiply that by 60 because we got to go from minutes to seconds. Q is 1632 coulombs, right? There are 96,485 coulombs in a mole of electrons. This compound has a charge of +3. It's going to take 3 moles of electrons to get you 1 mole of the metal M. So if we solve this, all right, 1632 divided by 96,485 divided by 3, we end up with 0.00564 moles. All right, we'll do a quick rearranging here. Molar mass is mass 1.11 over 0.00564. And I got around 197. All right, so it's a galvanic cell, all right, which means this metal is going to be reduced, zinc is going to be oxidized. We're going to multiply this by 3, and we're going to multiply this by 2. 2m plus 3 plus 3 zincs, all right, becomes 3Zn plus 2 plus 2n. Right? And then this is going to be 0.4 minus a negative 0.76, 1.16 volts. All right, so to do this equation, delta G equals negative N F E naught. So delta G equals negative, well, N is the number of electrons, that's 6. F 96,485, and then this is 1.16. Now, this answer is going to be in joules, so I don't care about the kilojoules part. If you did it, great. If not, I'm not going to take any points off, but just multiply all of them together. So this would technically be joules or negative 671.5. All right, so as this reaction runs, we need to make this concentration increase, and we need to make this concentration decrease, and then the cell will stop when the reactions are the same. So the electrons are going to flow into the solution, or they're going to leave the solution, and as they leave, they're going to make the ions increase in size. All right, and then the solution they enter, they're going to react with those ions, and they're going to actually decrease it. So they're going to flow into the larger solution A, all right, because that's at the cathode. All right, well, Q, all right, if we do our ions, it's anode over cathode. Well, if we just do our math real quick, all right, Q, well, our anode, all right, we said this is our cathode, that's 1, and this is 0.1, so Q is 0.1, Q is less than 1. At what value will Q, will the reaction stop occurring? Well, it'll stop occurring when P equals R, when the product equals the reactants, aka when the anode equals the cathode. So at this point, Q would be 1. So the first question is ID the electron on the right-hand side and explain your answer. So on the right, electrons are leaving this, right? And then they're entering here. So the electrons always leave the anode, right? And they always enter the cathode because that's the side being reduced, this is the side being oxidized. So who's being oxidized here? Iron. So iron or the anode. What's the sign of delta G? Explain your answer. Well, because E naught is positive, then delta G has to be negative, right? The negative ions are going to go, right? They go away from the electrons, all right? Sulfur is used to balance the charges, keep everybody neutral, all right? What would happen to the concentration of electron on the ions on the right beaker? So as the electrons are leaving, right, oxidizing, so the concentration will increase, right? The electron, right, we gotta use our reaction, right? Our metal is becoming our metal positive, and electron, this thing is gonna dissolve, increase concentration. All right, last part. We add distilled water to both sides. The cell potential increase, decrease, or stay the same. So I'm going to go up here. So we're diluting this solution here. So this one, all right, so normally, right, we would say it's, you know, what was oxidized over what was reduced. Right? But in this case, it's not 1-to-1. So if I make both of these smaller, right? I'm adding 100 mils. Let's say that makes the solution diluted by half. So Q is now a half over a half, but this one has to be raised to the third. So Q is really half over this, all right? So It might be easier if you look at it as just numbers. So this is 0.5 over 0.5 to the third. All right, and if we just type that into the calculator, Q equals 4. All right, well, if Q is greater than 1, then E cell, all right, it starts to go down. So E cell is less